Binomial theorem. So we saw in a previous video that the Pascal's triangle led to coefficients of expansions, and it looks something like this. We saw that 1 plus x all to the power of n equaled n choose 0 plus n choose 1 times x plus n choose 2 times x squared, all the way up until, well, we can have a general term in there, n choose r, x to the r, plus all the way up onto n choose n, x to the n. But this is only useful if we have 1 plus something. So we'd like to make a more general binomial expansion. And we can do that just by letting x equal to b over a. And if we do that, we're going to get 1 plus b over a all to the n equals n choose 0 plus n choose 1 times b over a plus n choose 2 times b over a all squared plus n choose r for the general term, b over a to the r, all the way up onto n choose n, b over a to the n. Now what we want to do is we actually want to factorize out 1 over a inside this bracket on the left. And if we do that, we're left with a plus b all to the n. And you can double check if that works. 1 over a times a does equal 1, and 1 over a times b does equal b over a. So we're just going to deal with this left-hand side for a little bit. So this also equals 1 over a to the n times a plus b all to the n, just using our index laws. We can bring this power down to this term into this term. And that's just going to equal 1 over a to the n outside of 1 plus b all to the n. And what we want to do now is we want to multiply both sides of our equation, so this side and this side, all by a to the n. And we're going to see what happens. So by multiplying this by a to the n, they're actually going to cancel out. So on the left-hand side, we've just got a plus b all to the n. And multiplying every single one of these terms by a to the n, let's see what happens. So we're going to get n choose 0, a to the n, plus n choose 1. Now we have a to the minus 1 times a to the n. We can just add those powers together and get a to the n minus 1, and we still have our b to the power of 1. Plus n choose 2 times in this one by a to the n. Well, we've got, this time we have a to the minus 2, and a to the minus 2 times a to the n is going to give us a to the n minus 2, and we still have our b to the power of 2. Doing this for the general term gives us NCR. a to the minus r times a to the n gives us a to the n minus r, and we still have our b to the r. Plus for our last term, n choose n, we have a to the minus n times a to the n gives us a to the 0, which is just 1. We'll write it in though. And then we have our b to the n. And all the way back here in our first term, you could imagine having a b to the 0 term in. And the reason I included that is so that you can see that the powers of a and b always add up to n. And now we actually have a much more useful expansion, a binomial expansion of two terms, because here a and b can be anything, and we can raise them to the power of n to get our expansion in terms of a and b. We can also write this using sigma notation. So let's go ahead and do that. So if we start off with r is 0 all the way up to n, And all we have to do is just write our general term in. So it's n choose r, a and b. B is to the r and a is to the n minus r. And this sigma notation can represent this series being added together. So let's have a look at some examples on how we can use this. Let's have a look at this binomial here, x plus 1 on x, all to the 4. And let's use our binomial expansion to expand it. So let's just write it down, a plus b, all to the n. We'll write it in sigma form, where we have r is 0, all the way up to n, of n choose r, a and b, b to the r, and a to the n minus r. So let's use that to expand it out. So we're going to have, or our n is 4, because it's to the power of 4, so we're going to start off with 4 choose 0. Our a is x, and our b is x to the minus 1, or 1 over x. So we start with 0, and we have 4 here, so 4 minus 0 is just 4, plus 4 choose 1, x to the minus 1, we're up to 1, and these powers always have to add up to 1, so you can know we have to write a 3 in there. 4 choose 2, x to the minus 1, we're up to 2, and the powers have to add up to 4, so that must be a 2. 4 choose 3, x to the minus 1, we're up to 3, powers add up to 4, so it has to be a 1. 4 choose 4, x to the minus 1, we're up to 4, powers add up to 4, so that must be 0. And yeah, we can just tidy this up now. So 4 choose 0 is 1, times x to the 4 is x to the 4, times anything to the power of 0 is 1, plus 4 choose 1 is 4, x to the 3 is just x cubed, and x to the minus 1 all to the 1 is just x to the minus 1. 4 choose 2 is 6, x squared times x to the minus 1 to the minus 2 gives us x to the minus 2, plus 4 choose 3, which is 4, times x to the 1, which is x, times x to the minus 1 all to the 3 is x to the minus 3, plus 4 choose 4, which is 1, times x to the 0, which is 1, times x to the minus 1 to the 4 is x to the minus 4. We can tidy this up still. So we can say this is just x to the 4, plus 4 times, when we have the same base, we just add the powers, so we're going to get x squared, plus 6 times x squared times x to the minus 2 just gives us x to the 0, which is 1, plus 4 times x to the minus 3 gives us x to the minus 2, plus 1 times x to the minus 4 is just x to the minus 4. And if we wanted to write it without any negative powers, this is going to be x to the 4 plus 4x squared plus 6 plus 4 over x squared plus 1 over x to the 4. Let's look at one more example. Let's say we had 3x minus 2 over x all to the 8, and we're after just the constant term. So this is the term without any x's in it. Now, we could go ahead and write out the whole expansion and check which is the constant term, but that would take a long time. So the best way to do it is actually write the general term of this binomial. So the general term is going to be, remember, it's n choose r, a, b, r, b to the r, and a to the n minus r. In this case, our n is 8, so the general term is going to be 8 choose r. Our a is 3x. Our b is minus 2 over x, so you've got to be careful. If there's a negative in between, you can include that with your second term. And this will be r, and this will be 8 minus r. So let's see if we can tidy this up a little bit. So it'll be 8 choose r times just using our index laws, we'll have 3 to the 8 minus r times x to the 8 minus r times minus 2 to the r times x to the minus 1 to the r. And the reason we're doing that, we need to bring the x terms together. So we're going to get 8 choose r. Let's just write our constant terms first. 8 minus r times, we'll write in the minus 2 to the r next. Now, this term here is just x to the minus r using our index laws. And when we have x to the 8 minus r times x to the minus r, they have the same base, so we can add their powers together. So this is multiplied by x. Now 8 minus r plus minus r is just going to give us 8 minus 2r. And to find the constant term, we know we need this to be 1. And in order for this to be 1, we need its power to be 0. So we need 8 minus 2r to equal 0, which means we need 2r to equal 8, and dividing both sides by 2, we know r has to be 4. So we can just go ahead and sub that in, so we'll end up with 8 choose 4 times 3 to the 8 minus 4, which is 4, times minus 2 to the 4, and obviously subbing in 4 for our power of x is just going to give us 1, because we'll have a power of 0. And throwing that all into the calculator or doing it gives us 4,587,520 for our constant term.